So I'm hoping we are live now. I'm just waiting for YouTube to confirm for me that we are actually live. So I'm just going to say hello for a few seconds. If you can hear me already, then do say hello. We always like to hear from people who are watching. Yeah, why? I'm going to just pause for a second here because I am not convinced this is actually live yet. If you can hear me, let me know. Okay. Aha, I can see John saying hello. So that is reassuring. I think what's actually happened, I have taken, I'm trying an experiment here of sharing one of my screens onto my iPad. And I think that my iPad has frozen. But so thank you to everyone who is posting messages now, reassuring me that you can in fact hear me. That's wonderful. So hello to John, who's watching from Switzerland, where we have lots of colleagues. So great to have lots of people in Switzerland. Yuka, hi. Noel, a regular, hi, nice to see you. Richie, hello. Connor, hello. Yeah, welcome to everyone. If this is your first episode of the eBPF and Cilium office hours, welcome. I'm sure we're also going to have some more familiar faces joining us. Always great to have your questions. So do add your comments, join in, anything that you want to share with us. We always love to hear from you. So today's episode, we're going to be talking about what's coming in the next release of Cilium, which is 1.11. It's kind of in the final phases of being prepared. We're very close to releasing it, but we're going to be joined by some folks from the Cilium team to share some of those features that are going into that new release. Before we get to that, let's talk about what's new in the world of eBPF and Cilium. So we've only got a couple of headlines today, but one of them is a pretty interesting thing that we found yesterday. BlackBerry have released a reverse engineering toolkit for, or a tool for reverse engineering eBPF programs. And this walkthrough, which I'm not going to say I've read in depth, but I have had a quick flick through. I think it's really, the things that I think are really interesting is where they actually start to reverse engineer some eBPF code. And we start to see things like, down here, there's some stuff about unrolling loops. I think there's some interesting information in this post about how eBPF programs appear inside the kernel, how they're constructed, what the eBPF virtual machine is actually executing. So yeah, that's interesting. I think there's also an interesting exercise to compare what this tool can do with what existing tools like LLVM, Object Dump, and BPF tool, things like that, whether this is adding some new capabilities. So if anybody wants to try this out and report back, we'd love to hear from you. Hi to Russell, good to see you. Right, the other big news that we have in Cilium land is that we have just announced the beta program for Cilium Service Mesh. And I think we should just take a moment to appreciate the artwork here that Vadim from the ISO Valiant team has put together. We love this. So we've been talking about how Cilium can act as the data plane for Service Mesh. Thomas joined me on an episode of eCHO just a few weeks ago. We had a good conversation about that. And we are about to release what we're calling a beta release for Cilium as a service mesh. And we are looking for people to try it out, help us make sure that it is reliable, test the performance of it. I've got to say the early performance numbers that I've seen are incredibly encouraging, but we want to make totally certain that they're as good as we think they are on first measurements. And we really also want feedback from users around what integrations you want, which control plane CRDs, which control plane tools you want to use Cilium with. So yes, sign up. Great. Travis has just said he's registered. Thank you. So right now there's a form to fill in just to give us a little indication of what your interest is in service mesh. There's going to be a feature branch for the service mesh capabilities for the next, probably the next release cycle of Cilium. So we are hoping to kind of collect a group of service mesh beta participants who we can let know about new features as they're added into that feature branch, and we can get your feedback as we add new capabilities. All right. So, Noel's saying, I have mixed thoughts about this. Let's see if I can bring this up. One side, one more service mesh, but happy to see the sidecar pattern going away. Yes, it will be, I think, really interesting to look at the performance numbers. As I say, early indications are that there's going to be some good performance improvements. So yeah, the interesting. So the interesting side of this is, yeah, we as a data plane, we're going to be able to integrate with other control planes. And I think, as Noel's referring, there are a lot of service mesh implementations out there. A lot of them are kind of achieving similar control plane controls in, you know, the same but different ways. So we're really interested to hear which you're using and what kind of integrations you really want us to add in. So, amusingly enough, one of my guests just had a bit of an internet outage, which is why I was kind of smiling nervously there. But it looks like his internet has recovered, so that's good. And I am going to try to welcome, if I can bring them in. I'm going to add Lewis and Christopher. So welcome to eCHO. And that was a brilliantly timed internet outage.
Murphy's Law, right?
So, well, I'm glad it recovered. That's
yeah.
That's the main thing.
Something can go wrong.
Yeah. It's when we get to demo time, that's where we really just have to hope we're not going to get
there we go.
All right. So both Lewis and Christopher are colleagues of mine at Isovalent, and they are working on Cilium. And yeah, we thought we would talk a bit about what's coming in the 1.11 release, and I believe we're going to even see a couple of demos. So yeah, I hope this is going to be an interesting preview. And as we go through, if particular features seem interesting to you or you have questions, please do add your comments into YouTube. So we'll also talk a little bit more about service mesh in a moment, but let's start by thinking about some of the other features that are going into this next release. And I think it's fair to say that a lot of the new features really relate to using Cilium on-prem, right?
Oh, yeah, definitely.
Yeah. And a lot of that relates, I would say, to customers who are, or users who are working with Cilium in the context of a broader network, maybe with BGP. So I think let's start, Lewis. Actually, no, before we go straight into the demo, why don't you just say a few words about like where you are and what you do?
Yeah, sure. Sorry, my internet was getting real choppy there for a second, so I might have missed some of your conversation, but it seems to be okay now. But just to give myself a quick introduction, I'm a software engineer at Isovalent. I focus on the data plane and networking technologies. I have a history in network engineering. I was actually a network engineer to begin with, and then went into software development. So it was just an awesome role for me, just getting back into one of my favorite areas of technology.
Fantastic. And Christopher, while we're doing introductions, do you want to say a few words to introduce yourself?
Sure. I'm Christopher Luciano. I'm a senior solution architect at Isovalent, where I help people get up and running and be successful with Cilium, as well as provide feedback and design direction for some of the more networking-centric features inside of Cilium itself.
Great. Well, thank you to both of you for volunteering to come on eCHO and show some of these new features that are coming. And I think it's fair to say that this is testing the demo gods a bit, right? Because it's not released yet. So hopefully people will forgive us if anything does go wrong. Fingers crossed. So, Lewis, let's talk a little bit about Bgp networks, perhaps. And I think one of the features you're going to show us is relating to how Kubernetes clusters can communicate across networks.
Yeah. So one of our efforts to facilitate on-prem is to integrate with BGP a little bit further than we do now. So when you create a Kubernetes cluster inside a data center, you're probably aware that your pod network is actually a private network. So what we're trying to facilitate here is the ability to distribute pod reachability across data centers via BGP. So I'm going to quickly whiteboard out the demonstration environment that we have. In our demo, we have one data center, and this is in New York. We have another data center in Dallas. In between these data centers, we have a WAN. In our case, this is the internet. In the New York data center, we've deployed a Kubernetes cluster. And inside this Kubernetes cluster, we're deploying Cilium. I'm going to change colors here. Also, in the New York data center, we have a BGP router set up.
Beautifully round circle there. That
Yes. My hand's not that articulate, so I'm relying on the software. And then in Dallas, we have another BGP router. Now, the point of our demo is to demonstrate that pods deployed here at this Kubernetes cluster become reachable here. To facilitate that, Cilium 1.11 allows us to configure BGP peering for the pod CIDR network to the BGP router here. Furthermore, to actually route the traffic across the WAN, we have a tunnel set up. And for our demonstration, it's just GRE, just for simplicity's sake. And then we have BGP peering across here.
Can you just say what GRE is?
Sure, GRE is just generic tunnel encapsulation. So because we're trying to route private addresses over the internet here, this big WAN that we have, we need to encapsulate those private addresses into the public addresses. So that GRE tunnel is really just creating a point-to-point network with the two public addresses of the BGP routers, and then funneling the private addresses encapsulated into the via the public IP addresses. So you can route them over the internet, essentially. You wouldn't be able to route the private addresses over the internet because it's not how internet routing works. Cool, so this is our demo environment. And then we can actually hop over to my terminal where we can demonstrate.
All right. I think we need to reshare your screen because it.
Oh, sure. Out. Not a problem.
Okay. There we go.
All right, cool. So to draw parallels to that diagram that I just had, I have 3 terminals set up on my right. The left terminal is just a copy and paste bin, basically. I'll just be moving commands over there. This first terminal is Kubernetes, the New York Kubernetes cluster that we deployed. Then we have the New York BGP router and the Dallas BGP router. So to even begin distributing pod CIDR routes, we need to configure Kubernetes with a BGP config map. And we can take a look at that. We're going to apply this to the cluster. And 192.168.1.11 is our peer address. So what this is configuring is saying, okay, when Cilium starts, it's going to go ahead and look for this BGP config map, and then it's going to create a BGP peer with this IP address. This IP address is our New York BGP router. So we're peering with the BGP router inside the New York data center. Then, so I'm going to copy these commands over to our Kubernetes cluster, and we're going to deploy Cilium. Quick note, this is the Cilium CLI. It would be similar flags on the Helm deployments, but these are the two flags that will enable BGP. This is the flag we're really interested in this demo. This is saying, okay, advertise the pod CIDR range of the Kubernetes host to BGP. So when this finishes installing, what we expect is that, oh, good, it already finished. So now that Cilium has installed, we're going to go over to the New York BGP router. Here I'm running FRR, which is a router daemon. It's an open source router daemon. And we're going to go and show IP routes, IP show routes. Maybe not. There we go. Cool. So this 172.31.0.0, this is our pod CIDR range. So what we've accomplished right now is we have Cilium advertising its pod CIDR range to the downstream New York BGP router. Now, if you remember from the diagram, this New York BGP router is peered with Dallas. So if everything went well, we should actually see the pod CIDR range over at the Dallas router as well. And we do. So we've now distributed the private pod CIDR range across the WAN to another data center. The last thing to do is just confirm that we can actually achieve connectivity. So what we'll do is over here, we'll go ahead and we'll deploy an Nginx pod. And then we're going to grab its IP. So this IP falls into that pod CIDR range. And if everything went well, we have a route for it, and we should be able to ping that private IP address. And we can.
From Dallas.
From Dallas, yes. So this is a good demonstration, especially when we're looking at on-premise deployments across multiple data centers. A lot of network engineers, as soon as they look at those kind of scenarios, they're like, okay, well, how do we even distribute pod information? These are private addresses. This is a step forward in that direction to be able to allow you to understand and dynamically create routes across multiple data centers to get to private pod blocks.
Awesome. So yeah, if you are running Kubernetes in different data centers, you can, I mean, it looks like you can effectively just treat remote pods as if they're local.
Yes, as long as there's a little bit of networking infrastructure that you'll have to deploy on your own, as far as tunneling and making sure that you can route these private addresses over a WAN. Your WAN might not be the internet, right? So it might be a moot point. You might not even need the tunnel. But just being able to distribute these private CIDR blocks is helpful, because a lot of times you might not be aware of the pod CIDR blocks that are coming up if you're just dynamically creating Kubernetes clusters. you now have a dynamic way for your entire data center to learn about these private blocks that are coming up.
Really cool. So if you're watching, and we already had Johan saying nice, if you are running Bgp Networks and Cilium together, let us know what you think. I know there's also been a few enhancements going into the 1.11 release that relate to things like load balancing. A couple of things that I kind of noticed in the notes that I'm going to just highlight. So one is topology aware load balancing. So Kubernetes now has a way of hinting whether pods are kind of co-located or located in a similar region, and Cilium in 1.11 is going to support being aware of this topology information, so you can do load balancing to pods that are kind of close to where the client is, for example. At least that's my understanding of it. Another one that I think looked kind of interesting is load balancing scalability, and I think this was contributed by someone from Google, but they've been scaling to beyond 64,000 backends. So that's a pretty significant scale of network. If you're watching and you're running a network bigger than that, let us know. All right. I think maybe, Christopher, it might be time. Do you want to start with the I don't know where you want to start. Do you want to start with the open telemetry, or do you want to start with the talking about service mesh?
Either or. We also have a metrics that we can talk about.
Oh yeah, metrics would be good. Let's whatever you're ready with first. Let me just make sure we're sharing the right screen.
Yeah. So before we jump into kind of some of the more some of the latest features involving Ingress and telemetry, I'd like to show some of the things that you can do already today with Cilium to both take a look at some of the layer 7 stuff we do at the policy layer, at our network policy layer, as well as some of the metrics that are exposed, so you could visualize a lot of this in your tooling like Grafana. So the first example that I'm going to do is I'm going to use a simple container that I've applied a network policy to. And this network policy, if we take a look at it here, is going to allow a pod to go out to api.twitter.com, very specifically api.twitter.com, where we can get down to that end level there. And we're only allowing this over port 443. So to kind of test this out a bit, I'm going to first jump into that container and run a curl the way that we're expecting it. And what I will get back is, oops, if I was in the right terminal. Is that I should be able to reach out to api.twitter.com. But as soon as I start hitting some other pieces of Twitter, I should start to hit that network policy. And that's what we want to show. And then we also want to show in Hubble what we're able to visualize metrics or Hubble flow wise to tell why we're not able to hit it. So when I try going to help.twitter.com, I get a connect timeout after a little bit. And then I want to see what actually happened when I tried to reach out to help.twitter.com. And if for whatever reason my GKE is a little slow today for me, I'm going to drop into Hubble to figure out why maybe I wasn't able to visualize that. So for the last minute, so you know I just ran this, if I'm looking at all of twitter.com, I can see that from my MediaBot source, I try to go to help.twitter.com, and this was dropped. Why? Well, because I had a policy that did this, and that's the policy that we just showed right there. So now if I try again to go in the clear, or sorry, over 443 to api.twitter.com, it'll work. But if I try to go to api.twitter.com in the clear, it should not work. Buffering. And we take a look for the last minute, going to api.twitter.com, and we get a similar thing. We tried from the media bot to go to api.twitter.com using port 80. We have a dropped verdict. Why? Because we have a policy that's denying that. Now you could use Hubble for more than this. Say you just want to generically go to a non-existent domain name. So fake.cilium.io should not exist unless Lewis just created it to mess with my demo. So when I try to reach out to that, okay, it still does not exist. And if I drop into Hubble to try to figure out why, I could take a look at all of the DNS traffic to try to determine why it is that might not be happening. So if I look, MediaBot, try to query out kubedns, and we see our query here, both quad A and for IPv4, and we got back a non-existent domain. So you can use Hubble not just for checking to make sure your network policies are really working, but to also see why maybe in the last few minutes I wasn't able to do these types of DNS queries. And the great thing about this then is that you can also open up Grafana, and we have a couple of pre-canned dashboards for all of this to allow you to visualize these drops in Grafana. So if you see here, I've got a couple policy denied. I've also got a couple of unsupported layer 3 protocol. This is just because the particular environment I'm in does not support IPv6 at this time. So I'm seeing some of those. You can always hide this sort of thing. But more important for our discussion is some of these metrics where we can see all of the HTTP responses. We can sort them by the identity of the service. So I'm using a GCP microservices demo. It's like a shopping cart example. It's good for this because it's got a lot of pieces to it. And I can see all of those pieces, the identities for them in my metrics itself. And I can see return codes. I can see methods in my metrics, as well as I can see latencies. So here I've got P50 and P99s for all of my different services. I can see, just in the past few minutes, a few peaks at points. All of this already available inside of Cilium. No need to add any of the additional stuff.
I think this is really important, not least because observability is it seems to be what everyone is looking for. I was just looking at the responses to people who've signed up to the Service Mesh Beta this morning. And one of the questions we asked about is what features of a service mesh they're interested in. And observability is the top answer from that set of people. So for that reason, I think the fact that we already have this kind of layer 7 visibility is probably really interesting to a lot of folks.
Yeah, this is great because now you have a dashboard that proves DNS is always the problem. That's pretty handy.
As we can see here. Yeah.
That actually seems like quite a lot of DNS errors. Is that
yeah, I mean,
empirical proof.
So anyone that's looked through the Kubernetes issues at any point in time will notice that a lot of them deal with DNS. So you'll see this quite a lot. Before I came to Isovalent, I was working on upstream Kubernetes full time, and I can't tell you how many issues that I've been CC'd on or have closed and cross-reference to maybe like a muscle error or something. The DNS errors are popping out. And to be fair, like sometimes, UDP is just not reliable as it was designed to be. And it's not uncommon that you're going to see some of these pops. So would I want to create alerts for each of these things anytime I've got errors? No, probably a significant amount of them, but I would not alert on every
Yeah.
DNS error. It's
like a
just
sustained
useful to see.
rate of error is probably
Yes.
what you want. Yeah.
I wouldn't want to be on that page of rotation.
Oh, man.
Moving on from this, though, as well, one of the things that we moved into is tracing. And right before we started the call, we were talking about like where would I want to use tracing? Where is that really useful for me? And where we like to envision it is similar to like your performance aspects. Like if I'm in the middle of an incident, is tracing super helpful for me? Maybe to identify if one of my downstream services is clearly failing. But in general, I could be using this quite a lot for performance testing reasons, figure out which service the request is spending a lot of time in. Are there any enhancements we can have for that? So one project which you can go and also use today is called our Hubble OTel project. And what we're doing here is we've tested this with Jaeger UI. We've also tested this with some hosted services like Honeycomb or AWS's tracing framework. And we're able to, because we're gathering all this information from Hubble already, we can intelligently create some of these traces, as we'll see in some of these screenshots here. I didn't set this up ahead of time, unfortunately, but you'd be seeing this exactly. So this is the Jaeger UI that we'll be looking at for some of these things. And what you can visualize in here, is a few of the various flows that happen throughout the duration of an HTTP request. So you'll see kind of a general span. You'll see all of the downstream services that a particular request needs to call or flows through. And you'll also see timing. So we'll see a few microseconds. We'll see milliseconds for depending on how long the actual request took. And all of this is just being gathered through the same Hubble events, similarly to what we showed before. So we're able to correlate all of this information based on layer 7 visibility policies you've created. We can also, crazily enough, do this for DNS as well, which we have an example for here. Yeah, so we can explore some of the DNS events as well. But this is also available to show today. So you can use Jaeger as you've already been using. Visualize things like your DNS request, all the various services that this had that's involved, as well as HTTP. Those are kind of the two pieces for kind of some of the open source stuff. The next kind of piece that we might want to show is the Ingress examples, kind of some of the newer stuff as well. So what I've done is I have a second cluster here set up for this. What we first wanted to do in this first iteration, and this is where we're greatly looking for a lot of feedback on, because we want to know what direction we should be taking this. What's most important to you? Is next steps going to be things like label-based, percentage-based traffic shifting? Is it going to be things like request retries, anything like that pops up? All of these things will be important for us to develop this out, and that's why we're kind of releasing it in the state it is, to get feedback very early. The first thing that we've started with is using the Ingress APIs that come with Kubernetes today, the v1 APIs, to create various Ingress types to support a few different backends. So we've completely addressed that. If we take a look at this TLS example here, the API that we have is very familiar to anyone that's used these for things like Ingress Nginx or anything like that. So our Ingress class name is set to Cilium in this case. And we cleverly call it TLS Ingress. This example itself is running in GKE at the moment, so it's backed by a load balancer that we can also hit. And we have two hosts in this example. So we've got one that I'll use for demonstrating gRPC communication that we're able to handle, and then one just for regular HTTP. We can view that through the browser. So we have the details page, we have the product page, and then most importantly for the security conscious, we have supported the TLS pieces as well for each host. So in my browser, I'm able to actually go to this site. I'll reload it just so you know I'm not kidding. And I'm hitting that product page. And this is all backed by a real certificate, which I generated through Let's Encrypt. Excellent service. And it's a real certificate. So I don't see any errors about an insecure state or anything, and all that is bundled together. So I can kind of push through. I didn't install Cert Manager directly. What I did is I used commands, the certbot commands.
Okay.
And then you just kind of pass in, what you want the domain to be associated with, and like an email address. And then you get the cert, and then you create the secrets. Such. You're putting in your private key, the full chain and everything. And then that's what we're associating right here for examples. So where we see this being very useful up front, and what we've been trying to test this with is, so in the book info example from the Istio team, if we take a look over here, as I refresh this page, we'll see stars kind of come in and out. Sometimes they'll be colorized, sometimes they just won't be there at all. Where we'd like to start testing out is, because all of these different services are, or all of these different pieces right here are backed by different pod types, we can do an integration with our cluster mesh service, so that you could have technically different versions of this service. So the version that that has stars, the versions that has black stars, the version that has no stars. Some of those could be in one cluster, some of those could be in the other cluster. And if you have them connected via cluster mesh in Cilium, you can intelligently load balance even between two clusters with this same Ingress controller. So that would be a neat thing for us to try out, and certainly direction that we're moving in.
Right. So right now, all of those different versions of that service they are appearing as one service. So we could hit any of those.
Yeah, they're all included in the service definition here. So, well, we could create the Cilium global service annotation. We could slap those on here, bring in a second cluster, and then test out even having the Ingress fully in one, and then all of the services in the other cluster.
Yeah, that's pretty cool. Yeah. And then we could run them over Bgp network.
There you go. Would one of the use cases of that be like A/B testing for like QA, if you wanted to kind of roll in an app and then route kind of like 50-50 or something like that, see if...
Yeah. So those are kind of next steps. So under the covers for a long time, Cilium has compiled in a version of Envoy into our agents. And that's what's driving a lot of this. So I don't have an explicit Ingress controller, if you'll see here. It's just a little slow querying. But I don't have an explicit Ingress controller in my group system, nothing with Ingress Nginx. We still have the layer 7 backend as required by Kubernetes, but the actual Ingress is being handled by the Cilium agent itself. And that's because this is hitting Envoy code, which is only ever in your data path if you're using these layer 7 examples, creating policies, doing any Ingress things. this is not going to be hit every time. So there's no performance cost if you're just doing normal pod-to-pod communication. But this also enables us to take advantage of any features that Envoy already supports. So things like percentage-based communication. Even moving forward, we could be doing quick termination if we really want.
Yeah, and
so
I think in the beta release, it's going to have support for configuring those Envoy settings through a CRD, right?
Yes. So we've got a very low-level CRD where one could dig in and start just playing with a lot of those things. It's basically a CRD that looks very similar to a Envoy like v2, v3 sort of config file. So you could dump that into the CRD that we're using and kind of ship off. So our v1 Ingress APIs are the next layer atop that knows all of the proper settings, because manually messing around with the Envoy configuration, as mentioned, is very low level and isn't the direction that we want to have as the normal path. So we want to instrument and create further APIs in order to give you some more high-level things, and you don't have to drop down to that lower level. And that's part of the program that we're looking for. So if request-based routing is something you want to do, percentage-based routing, header-based routing, if those are the important things to you, then those are the things that we'd like to do next. But in the cluster mesh sense, you could kind of simulate this by, having the global service only talk to things in the secondary cluster. So you could get away with it on that end. It's just not going to be like an integer you can throw in there and say.
Yeah, it totally makes sense.
Very cool. So yeah, the first steps towards an entirely Cilium-based service mesh right here. Awesome. And are there any other parts of any other features that you want to show us?
Mostly just the gRPC example. So we're using gRPC curl for the secondary hipster service. So you have to pass in, the proto for this example, which I can briefly show here. It's a standard proto definition for the microservices shopping cart GCP application. So that gets passed in. I'm hitting a different host than that of what I'm using for my book info example, and I'm trying to hit this piece.
So that was another
so
Ingress. That was another host defined in the Ingress, was it?
That's correct, yeah. So the first host was the book info app, and then for gRPC, I'm using a second host just to show that we're able to have multiple hosts in here and everything. But this one specifically for the gRPC example, unfortunately, there's no easy way to show gRPC through the web.
Why does that one, after the line that you've got highlighted, it says HTTP? I don't know why I'm expecting it to say gRPC.
Yeah, so we're still using HTTP2 as the primary protocol for this. It's just the method of using gRPC instead of your regular REST sort of based stuff.
Okay.
Yeah.
And that's essentially all I have at the moment.
All right.
Let us know which things you're looking forward to, and we'll have further examples as they come out.
Very cool.
Yeah. So if you're watching and you have service mesh things that you would like to see us implementing, we'd love to hear about it. We'd even more love it if you sign up for the beta program, because then we can kind of have a bit more of an in-depth conversation than we'll manage on YouTube. Thank you to the folks who have already registered. I'm just going to show this comment from Travis earlier.
Nice.
All right. So I think we probably, I don't know if there's any other highlights or anything else that is coming in 1.11 that you want to mention. I think I mentioned my highlights before, but just having a quick look. Yeah. All right.
I mean, a lot of cleanups happening. The pod CIDR support is certainly a big one, one that we've been kind of waiting for a while. This is just the next step. We already had the service CIDR announcement, and this is just the next step for if you have a very advanced BGP use cases and everything.
Yeah, maybe just a little bit to say on that is that there is going to be quite a bit more work coming down the pipe for BGP itself. We're going to probably start scoping out what we're calling BGP v1 because BGP is in beta right now. With that, you'll get dual stack IPv6 and IPv4 support. A couple other niceties that are kind of missing from the feature right now. So if you are interested in the BGP feature, just keep an eye out. We'll be making some noise around that the upcoming weeks or so.
Great. So keep your eyes peeled for the 1.11 release, which I think will be out in a matter of days. You can obviously hear about it immediately if you are in the Slack, in the Cilium Slack, which you'll find a link in the show notes. I think probably a lot of you are already there. And of course, we'll also be tweeting when that release comes live. So I think I'll just show a nice comment from Siva saying, thanks, folks, interesting talks. If you have any last minute questions, get typing, get those in really quickly. Otherwise, I think we will call it a day. We'll say thank you very much to Lewis and Christopher. Sometimes at this point, someone will come up with a question and I'll be like, oh, we've just said goodbye, but just another question.
Yeah. Always available on Slack too. So if something comes, to mind afterwards, just pop it in there. Feel free to add us.
Absolutely. Well, thank you so much to both of you for joining me today on eCHO. And Lewis and Christopher and I are all on the Slack, so do feel free to get in touch if you have any questions, or indeed if you have topics that you would like to cover on a future episode of eCHO. We're always interested in ideas for that too. So with that, let's wish everyone a lovely weekend, and we'll see you next week. It will be Duffy back in the later time slot next Friday. Thanks very much, everyone.
Bye.